Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Today we are having sort of a special event on the stream. First, I will be doing the regular episode of Handmade Hero where we will be doing some coding. And this is actually going to be some pretty, I feel like this is going to be some fairly instructive coding for people who are interested in code architecture. I think we're going to be doing some interesting things today, just in terms of like sort of showing how some code transformations work and stuff like that. So I hope you'll enjoy that. And then after the stream, at about 8:30, basically whenever the stream is over, so after the Q&A, we will be going to a special mock debate between myself and Sean McGrath. You probably have seen some of his work. He actually just recently was one of the main guys on N++ on the PS4. And he is considering doing a free-to-play game as his next game, and he is a little apprehensive about free-to-play. As I guess he is not completely sold on the concept, perhaps I should say, or maybe he feels a little uneasy about it. And he wanted to sort of have a public discussion in the form of a debate where I'm sort of taking the devil's advocate position to all of the reasons why he is thinking that this might be a good idea for him. So I tried to prepare some interesting points for him to think about, and we'll see how that goes. But I'm relatively excited for it. I think it'll be pretty interesting. And I'm also kind of interested to hear his perspective on it, because I honestly don't know that many people who think free-to-play is a good idea, but also are apprehensive about, he's obviously very aware of the problems of F2P, but still thinks that maybe it's the right decision. And so that sounds to me like a more interesting position for me to hear about and explore than the standard people who are just like, it's capitalism, it's whatever, it doesn't matter, as long as people buy it, it's fine, right? Or whatever, like sort of the more traditional F2P Zingarian position on these sorts of things. So I hope you'll join us for that. Again, you shouldn't really have to do anything, assuming that we don't have too many technical difficulties. You can just keep on watching Handmade Hero. But I believe Sean will also be trying to stream it on his channel as well. So if you do subscribe to or watch his streaming channel on Twitch, you should be able to catch it there. So either place will work. All right, that said, today we are on day 210 of Handmade Hero. And so if you would like to follow along with the code that I am doing here, you should do that by unpacking the previous day. So unpack day 209 source code, and then you'll be exactly where I am at the moment. So yeah, where were we, right? Do you guys remember where we were? I hope you do. We ended the last stream at a place that I was actually pretty happy with. I was pretty excited about where we ended up getting, and the reason for that was because we had finally gotten to the point where our debug system now supports both profiling and data written through the same stream. And it all kind of gets collated after the fact, which means that if you kind of turn it off, it's just not there. It doesn't really cost you anything. You can also compile it out and do all those sorts of things. And it also means you can kind of look back over time. So it means that when we're displaying data, we're not just dumping it to the screen. We actually have 32 frames worth of back data we can even go look at, and other sorts of kind of neat stuff like that. So I'm pretty interested in this. It's kind of neat. It's just a kind of a neat thing. And so what I want to start doing today is getting us sort of more towards a well-working code base, because basically what we did is we did all the stuff necessary to make all these things work, and it's very exploratory. I've never written a debug system that really works like this one does. And so I was just trying to figure out sort of how do we structure the code to allow all these things to work in a nice way. And so now I kind of want to start taking what we have there, now that we see it working and it's all fine, and start to sort of piece it apart into something that I'm more confident about its behavior, how it's structured, and its ability to kind of add things and so on. So for those of you out there who are novice programmers, who are a little unsure about how to make architecture decisions and stuff like that, this stream is sort of going to be largely about that sort of a thing. So the first thing that I would like to point out here, kind of want to show you a fairly obvious thing that I think we should start with. And this is, like I always say, I'm a big fan of compression-oriented programming, right? Which is sort of a made-up term that I use. I don't really know if anyone else uses it, but basically what it means is trying to allow code to be exploratory, be free, be fast and loose, and then the way that you sort of start getting architecture out of a place that you don't really know what the architecture should be is to start looking for how things tend to work and then taking common pieces and collapsing them into things that can be used in more than one place, right? So it's this concept of taking sort of a big repetitive mess of code and going, oh, I see that this is doing some things in common. I can compress that out. I can compress this out. And until you kind of get it down to something that's nice and concise and where things are only done in one place and so on, right? And so that's what I'd like to point out here. So if I just start thinking about it, there's just a lot of code, right? The debug system took several days. I think it was like 10 or 20 days, which is, 10 or 20 hours. So I don't know, half a week, something like this, of us typing in code, trying things and whatever. And so there's a lot of code there, right? There's a lot of stuff we wrote. Not all of it was necessarily considered holistically. It was just us trying to sort of get to the point where we felt that it was doing the sorts of things we wanted it to do, right? And so one of the things that you'll notice is we have a lot of things that sort of do similar operations, right? And have things that look kind of similar. So if you look, for example, in our Handmade debug.h, and you look inside our Handmade platform.h, so in Handmade platform.h is just the debug usage code. It's the code that people use to access the debug services when they need to access those services. And what you will see there, right, is you've kind of got this structure in there that's like, okay, here is a debug event. It's something that goes into the debug log. You can see in there that it's kind of got a type which has some sort of different data members that it might be, like R32, U32, S32, those sorts of things. And we have some things in here like a union that stores different types, like this like seconds elapsed or whatever, and then some pointers to things and some ints and unsigned ints, whatever, right? Now, if we go back over here to our Handmade debug.h, you can see that what we have here is almost the exact same thing, right? You can see that we have this notion of a debug variable type, right? And it's got a lot of similar things in it. Now, there's some things that are not, like we've got these counter thread lists and the bitmap display and those sorts of things. But we've got this whole set here are like the same sorts of things, right? And then if we come down to look at an actual debug variable itself, you can see that we have almost the exact same things in these two sets of places as well, right? So there's just a very, very significant amount of overlap in what's happening there. And there's a reason for that. It's because this is actually a conduit, essentially now, to this system. Now, we didn't know that when we designed it, but that's just how it started to shake out. It means that basically people who want to put data out to the debug system, they shove the data in here, whether it be a profile counter or a piece of data from a struct that they would like to inspect. It's all going into this stream. And then later on, that something gets sort of constructed into a hierarchy here for the debug variable system so that it can be displayed or stored later or things can happen to it, whatever we might want to do, right? And so the part about that that's significant, and the reason that I think that's worth noting, is because every time we want to add a new type to our debug variable system, it would mean we'd have to add it in two places. So although it's not maybe the biggest deal that it's duplicated this one time, what it really means is that going forwards, all changes that we will ever make and all additions we will ever make to the types of values that we can display at a base level that are considered sort of atomic types that are tracked in the debug system will incur a cost where it is created on both sides, and it's just a lot of busy work for not a lot of payoff, okay? So what I'd like to do first is take a very simple code simplification step there and try to make these two things use exactly the same code in all cases, so that there's no longer this concept of currying things around and translating from one to the other and switch statements that have to crack out one to put it into the other one. All of that is just busy work, and we would like to basically eliminate it entirely if we can, right? Okay. So the first thing that I'm going to do, excuse me. The first thing that I'm going to do is I'm just going to go ahead and do the simplest possible thing in terms of collapsing these guys, which is to say that I am just going to full on say that debug variables can just contain a debug event, right? So I'm going to say, instead of storing any of this stuff the way that it's being stored now, I'm just going to allow it to be stored the way that it is stored here, right? And so I'm going to go ahead and take that and say that's what I would like to do. Now, there is something that's a little bit annoying about that, and this is sort of the thing that we were talking about before, which is that some of our base types here, like v2, v3, v4, and rectangle 2, so on, those are not actually defined anywhere in these sort of platform code, because they exist only in the actual Handmade hero code. And so I really don't know whether we want to move those in or not, but I kind of think that it might be nice if we did, right? Because I like this method of accessing things here a little bit better than this method of accessing things here, because it better represents exactly what's going on, right? So I think, like I said, this is the step that I want to take. So the first thing that I'm going to do is I'm going to actually have this thing work effectively like this, right? So I'm going to sort of move the data block stuff from this over into here. I'm going to make it a mirror at first. And then I'm going to fix anything any problem that caused. So I'm just going to say, because I like it better, I would like all of our stuff here, our v4s, v2s, all that kind of nonsense. I'd like all of that stuff to now be sort of considered base types. So they're just going to be in here because I think they're important enough and we use them enough that I would like them to sort of be accessible to the platform layer as something it can use and something that we can use in the interface boundaries and so on. I think that's just a reasonable thing to do. So I'm going to go ahead and put that in there. So now we've got v2s, v3s, and v4s in there. And I'm going to do the same thing with rectangles. So inside the math library, we've got rectangles as well. And I'm going to go ahead and add those. So here's them, right? And I'll grab them out, and I'll just put them in here. OK? So that's all I really wanted to do there, just to start with that. And that means that I can also add now the rectangles directly into the API themselves. So inside debug event here, I can say we also have rectangle 2, right? And rectangle 3. All right, and now I'm going to deal with the fallout that caused. Also, note that the simple preprocessor at the moment I don't think is preprocessing Handmade platform.h, so I'm going to go ahead and let it do that as well, since now we've got introspection in there. And so let's continue on. All right, so in order to port to that, what we have to do now is take Handmade platform.h and all the places where this stuff was happening before, where we sort of have these debug values, stuff that's happening. All of that stuff needs to now be handled properly for the new types that are there, right? So when we have an S32, I'm going to take that S32. When we have a U32, I'm going to take that U32 and so on and assign it directly to the right place. And then, of course, I have to actually also figure out what I just called those, because I don't remember, because I am old and forgetful. So here we go. Let's go ahead and get those. There's a real 32. There's a U in 32. And there's an int 32. OK. So then these guys are even more straightforward. These guys have a vector 2 or whatever it's called. Let's see what that is actually called. This is where I wish Emacs had the concept of storing back state for different views. Mr. Fourth Dimension, if you're out there, I can explain that in more detail sometime. If you are interested in adding it to the awesome editor that you are constructing. OK, so we've got vector 2. We can now just assign that directly, which is nice. We've got vector 3, which we can also assign, and that's also nice. And we've got vector 4, or sorry, rectangle 2. Here we go. And rectangle 3. And that also cuts down on some potential typos that could have been happening in here, like for all we know. We don't really know what's going on there. Furthermore, now that those things are defined, this stuff can kind of come out of here, so it doesn't have to be in there anymore. It doesn't have to be in the math one. It can actually be in here, so this is kind of consolidated a little bit, which is actually a nice thing, in my opinion. So there's all that, and that's good. OK. So I'm going to go ahead and compile that, see where we're at. OK. So now we've got to fix the vec pointer one. We don't have that one at the moment. So that's actually being used sort of in here for our open data block stuff. That we can still, I guess for now, since we don't really have any particular opinion about how that stuff should work or any real reason why that stuff has to change, we can leave just that one alone for now, and later on we'll think about what we want to do with that, right? Okay. So this is going to be an R32. The seconds elapsed value is just going to be stored as an R32, obviously. So that's all good. And then in here where we've got sort of the debug event translation, I'll just really quickly go ahead and translate it over directly. And again, our goal is to get rid of this whole switch statement to, just entirely. We don't actually want it to be there at all. But I'm just kind of doing this mechanically so you can see each individual step. I might take a larger step than this normally if it were just me, but I'm going to kind of do it a little bit more slowly just for anyone. Again, this is kind of more of a stream for people who are sort of new to architecture. I want them to be able to see what's going on here. Okay. Okay, so in Handmade platform.h, now that we've got the introspection stuff kind of hanging out in there, and which is something that we probably would even continue to do if we were doing introspection, it means that these guys should really exist up here in the introspection code, something like this. So I'm going to leave that there. And now we've gotten to the point where we're pretty much done. I have to change the seconds elapsed thing. Again, that's not actually stored that way now, stored in the real 32, because we kind of got rid of that special purpose code. But now we're back to the point where we should be working, and you can see that we're sort of passing the same values and seeing the same things that we were before. So that's exactly where I wanted to be. All right, so now let's get rid of some code. Friend of mine from a long time ago, someone I was more of an acquaintance, someone I worked with at Microsoft very briefly, we were interns there together, once said a very, I think, wise statement. He said, "Some of the most productive work you will ever do will be with the delete key." This was his statement, and it's true. So basically what I want to do here is start to delete some code. So here I am in debug variable, and what I would like to do is start by saying, well, I should be able to just use the debug event structure directly in here as one of my types, and then debug variable type should not actually need to sort of have any additional type information in it, right? That debug variable type can just be like that it was an event, right? And that should be sufficient. So I should be able to get away with doing something like this, right? And what I can do now is when I add a variable, instead of having to have all these different kinds of variables that we're adding here, which are not particularly useful to us, where we have to kind of have all of these different cracking functions, what I can do instead is say, well, if I want to add a variable, maybe one of the variable types that I add is just going to be straight up an event, right? Now, again, this code actually is all code that we can probably get rid of as well. All of this stuff and the sort of those those toggles and stuff, I feel like probably eventually we're going to want to do in a slightly different way. And in fact, what I may do for now, since we're not really working on this part of the system, I may just kind of get rid of this code in its entirety for a moment. I may say, let's just kind of let this code sort of sleep for a second, where I'm going to kind of like just say, yeah, the debug variable stuff, let's kind of let that be. Let's let it do its thing. In fact, how much of this could I actually remove? Can I get rid of most of it for the time being? I don't actually know, but we'll see if we can or not. Let's see here. That's going to be in Handmade, debug.cpp root group. There it is. All right. So I'm just going to say that this stuff isn't ever going to happen. It's just not going to happen. It's just not going to happen. Okay? Not going to happen. Never going to happen. Didn't happen. Not going to happen. So in here where we do all of this stuff, I'm just going to get rid of all of that and just concentrate on the other part of it. So when we have a debug variable event, right, something like that, what we're going to do now is say that, okay, all of this stuff that we were doing before, where we were printing out all of these additional items, right, what I want those to be is that's sort of a separate thing now, right? That's going to be a separate thing. So this is all going to be under debug variable type event, where if we see an event, we know that now we're actually going to look at a secondary value to determine this, because this is like a whole shared system that doesn't have to go with any of the other stuff that we're, that we might put in here, right? And we may be able to collapse it down even further than that, but at the moment, that's really all I want to focus on for now. Okay, so what that means is that all of these types that we were previously using, again, have gone away, and we can just use the types that we were using inside the debug system directly. So now they are not duplicated anywhere. They're just going to be let's see here. There we go. They're just going to be shared, so we can, when we change one, we automatically get that change in the other one, and there's no need, all we have to do is add the minimum amount of code necessary to support it in the other system. There's no busy work anymore, because I hate doing busy work, right? I wouldn't be so into metacoding if I didn't hate busy work, right? So in the debug event system, it looks like right now there's no bool 32 at the moment, so I'm going to go ahead and add one. Temporarily, even though that it doesn't actually get used here yet. I assume that it will at some point. Okay, so there's our debug event v2, there's our debug event v3, there's our debug event v4. Okay, and then we also probably want to do something where in here we can support the other types that we had. We have rectangle 2, and so rectangle 2 is just going to be like something like rect2, and it's going to be like that sort of a thing, you know what I'm saying to you? So we've got a rectangle 2, min x, rectangle 2, min y, rectangle 2, max x, and rectangle 2, max y. So that's a rectangle 2, and the rectangle 3 is going to be the same code, right? Exactly the same thing, it just now prints out one additional element. All right, so now we handle all of those, and that's nice. But we need to also get them out of a different place. So now it's going to get just out of var event dot whatever the thing is, right? And so you can kind of see me taking a look here at what's happening. There we go. Event, 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 and event, 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 event. Okay. So, that I do not know whether, oh, that is because this was something that I was trying to turn off. All right. What is happening here? Introspection is only supported for structs right now. Oh, nice. Yeah, this is something that we never actually did. It doesn't actually affect us at all, but this is kind of funny. We didn't actually write any code to ignore the fact that if we try to do a file in which the introspect itself occurs. That's probably to do. Have the meta parser ignore pound define its own pound define. Yeah. So anyway, at this point, I don't really know what that debug max variable stack stuff, why that really has to be there anymore, but it does, at least for our traversal, I guess. That's kind of the case. So inside the debug variables, I'll just let that guy continue to be outside, and that'll be fine. All right, so in here, when we're doing hot interaction types, and we're working with variables and stuff like that, this stuff is all going to want to use sort of the other information as well, right? So now, in theory, what we should be able to do is some sort of a situation where we look at whether we're doing events or what exactly we're working with. So again, this is going to have to be something where we just kind of do a two-tiered look, right? So if we want to do something like debug variable type event, then we can do things where we just take a look at what are the different things we might, want to look at in that system. And again, this is just the exact same thing as we were doing before. It's just allowing us to use that that guy sort of indirectly, right? It's allowing us to use a different system for storage. And again, I'm not necessarily saying this is the last one I want to do. I just want to get it working in a way that it's just kind of included now. So yeah, so debug event B32 and debug event R32 are the two that existed in here. Oops. And so that's all we should need. So if we take a look at this guy here, we should be able to look at that event type and do the comparison. Everything else should stay the same. Nothing really interesting happening there. So in here, this stuff, again, we don't have at the moment. And the reason that we don't have that at the moment is just because we're sort of changing up how we're doing those trees and stuff like that. So we'll get to those, again, as we continue to clean stuff up. We'll kind of move those in. And so here, again, with debug end interact, this is the case that, again, we've got sort of a two-tiered thing. If we're working with an event, then maybe we've got something that we want to do. And in this case, there we go, our event type, we just want to do something with that bool. OK. So that's fine. Nothing particularly odd going on there. That's just, again, this debug event B32 thing. And then let's keep moving down. So, oops, that's not an arrow, that's a dot. OK. So in this case, we're just going to set the bool. This is actually editing that bool. And again, we're just using the exact same logic. Everything is exactly the same. I don't know why I decided to name those. I named those kind of weirdly. I don't love it. I should probably change the way that I'm doing that. That's my suspicion, but what are you going to do? Anyway, so yeah, again, like just doing the bare minimum here to translate this code so that things are starting to line up a little bit better, right? OK. So let's see where we're at. So in this case now, all of this stuff, all of this code here that was doing this translation before, all of this code should actually now not have to do anything at all, in theory, right? So all of this code is if anything came through, if any kind of debug event comes through at all, right? If we see any kind of debug event, then all we really need to do is just capture it, right? We just need to capture it as a data block, right? And in fact, I think what we probably want to do is say, you know what, just it doesn't matter what, since we don't have to do any different code now, it actually doesn't matter. Any event that we don't understand, we just save as data and assume that someone will try to print it out later. And if they can't print it out, then it'll just come it'll just come through as like, I don't understand this thing. So now all we have to do is say, okay, we're going to make an event, and the event equals the event we got. So all that code is gone now, and it's just a straight up pass through, right? It just comes straight on through. Except I need to dereference it. There we go. So all that code and all of that nonsense went away, and so that's pretty handy. I don't know what happened here. Did we? This probably never initialized our tree stuff when I came out to. Where are you? Because there is no debug tree here anymore. I got rid of all of our stuff. Which admittedly is not something you can necessarily do directly, although I want to be able to make sure that that is allowed for now, so I'll make sure that that's okay. Yes, you can see that in this case, group can't really be 0 here, so I'll just go ahead and make sure that that's allowed. We'll just say if group, and we will go ahead and push that out. Yeah. Yep. All right. Oops. Don't want a breakpoint. So now we're, again, running everything through just one type of struct now to encapsulate debug data, which, again, is a nice little collapse that I'm very happy about. I like the fact that we did that. And that's all well and good. So let's continue onward from there and see what we can do, right? So now inside Handmade debug, or sorry, Handmade platform.h, right? this is now the canonical way that things are actually stored inside the debug system in general, right? Meaning we're actually just, this is the place that we would add new values if we want new values, and these are the values that it stores inside itself as it goes, right? And that all just feels much better to me. So that's a good thing. And so the question now, though, is we kind of have this two-tiered thing happening inside this, where we've got, this sort of debug variable type thing happening, and we've got, one that it breaks out in here, and then we've got these other ones in it. And so the next question that I would have, that's kind of a relatively obvious question, is since these are just debug, since there's no there's really no reason for us to have a two-tiered test thing there where we're actually sort of swapping those out. We could choose to simplify things even further just by merging these two enumerated types together, right? That's something we certainly could do if we wanted to, because remember, this one is only an 8-bit thing, so we could just jam all of these guys into this type itself and just have them all just work that way, right? So we could do something like the lower 255 entries are reserved for the ones that actually go in here. And then all of the other things that happen, like this counter thread list and all that stuff, just exist higher, right? So they would be something like this: debug event, first UI type or something like that. And we could even call this just debug type instead of event type to signify that. But we could do something here where we just say, okay, we start at 256 and we go up from there. And then these guys are just going to live in here, right, as part of this, right? That's something we could do, and that would get us out of the business of having sort of this other, this other sort of, pre-existing value. All right. So I don't really know whether I care about that too much or not, but it just seems to me like overly complicated to have two types there for no reason. So it seems like maybe I want to collapse that down a little further. So I'm going to try doing that, and I'm going to see what happens. And what I'll do here is I'll just say, like, I'll have a single debug type kind of a concept, and I'm going to just, do it like this. OK. So the first thing I'm going to do is I'm going to call these debug types, and then I'm going to change anywhere that was using them before to use something else, right? So we've got this set up the way it is. Do it like this. Yeah. So I'm going to go through and say, OK, debug event type equals debug type. And I'm just going to see where those sorts of things occur. So let's see, frame marker. It's debug event. OK, so debug event underscore equals debug type underscore. And then I'm just going to go ahead and get rid of all these things so that they're all just talking about debug type. And then I'll recompile. Then in here, I'll just do the exact same thing. So these all do debug types as well, right? There we go. OK. And then inside Handmade debug, if we go down and look at debug variables, right? So if we look at how this works now, and we put an event in there, we have a debug variable type up at the top. I could just change that to being a debug type itself, and now that would just be, would be used directly. And so what that would mean is that when we add one of these things, when we add the type here, we would just add whatever the events type is, like so. And now we wouldn't really have to use that secondary switch method anymore. We could just switch directly on the type and know that they're all kind of stuffed up in there specifically, right? So I'm going to go ahead and do that as well, just to see what becomes of it. So here we go. This is going to be oops, not that. Not that, I say. And not that either. Let me go into handmade debug.h and also get rid of debug variable type, because this should go away, and this is one of those now. There we go. Okay, so now when we're doing these switch statements here, these can just now be promoted back up to the top, like I said, which is kind of what I wanted to do. So you can kind of see them all happening together, and that's all very well and good. And you don't have to actually sort of do step downs to sort of crack those types out as a separate thing, right? And similarly, through all of this, debug variable type underscore is just going to be debug type. Oops. Debug variable type underscore equals debug type underscore. There we go. I'll just replace those. Okay. And now debug type event, anywhere that we saw that, we can just re-promote these guys up to the top level where they were before. And we know that that will be fine now, right? And so that gets us out of the business of having to do double switch statement, the sort of cracking of the double switch statements there. This is a debug type now. Okay. And that should take care of that, right? So now I think we're all good. Everything should still be working as we expect it to. And that's good. So we're getting, we're sort of making slow but sure progress towards something that's a little bit more, coherent and a little bit more thought through. All right. So that's all nice. And I think this is starting to look a lot nicer now, because now we just have that, and in our Handmade debug is starting to simplify, right? We don't have sort of this whole other situation here with all these different sorts of things. But we still have got a lot of business in here. There's a lot of things going on, a lot of moving parts, and it's not necessarily clear that all of them are doing what they should be doing or that they're actually necessary. So now let's take a look at something a little bit more direct. So, okay. Now if we start to take a look at what is an actual debug variable, well, our debug variable is a thing with a type. It's got a name, right? So it's a type and a name. And then we know that it could be a debug event. So that could be there. Or it could be one of these things. So what is a debug profile settings? Well, debug profile settings is actually meaningless. Debug profile settings actually doesn't exist anymore. And the reason it doesn't exist anymore is because we moved the concept of things like settings out to stuff like the debug view, right? So that's gone now. That doesn't actually need to be there. The code compile is fine without it. A debug bitmap display is just a bitmap ID. Now, if we wanted to display a bitmap ID now, what we can do is we can just go ahead and move that bitmap ID directly out of this, right? And into the debug system, right? So the debug, the bitmap IDs, those can now come directly through here. So, something like a bitmap ID can be in here, or a sound ID could be in here. So we could see those when we're in the code. We could just output something like a bitmap ID, and then we would just know that we have one of those things that we want to display, right? So instead of needing to have this could be in the event itself, right? So I'm going to go ahead and try to make that change as well, okay? So I'm going to get rid of debug bitmap display, like so. And then I'm going to compile this. All right. So the first thing we need to do is actually get those type definitions in here, which again requires us kind of to move things in a little bit. But like I said, I'm okay with that. It's fine with me. I don't care that those get moved out to the platform layer, because it doesn't really harm the platform layer to have those in there. So I think that's in the file formats thing. I don't actually remember. Yes, it is. So there's our different IDs, bitmap sound, that sort of stuff, right? All of those things are now going to come in here. So those are just little base wrapper types. And the pragma push on these guys kind of needs to be respected, right? So I would like to keep my pragma push. I'd like to continue pragma pushing that. So I will do pragma push here. And pragma, so there we go. That's again just the packing where we want those things packed. Now granted, we don't really need to do pragma pack on those, because I think they only have one variable, so I don't know that actually makes any sense. It's probably worthless, but it's interesting to just leave it there so people know those are things that have to remain the same, because they go in and out of files, but whatever. So anyway, Here we are with our get bitmap code. So now this stuff doesn't exist anymore. So we would have to do something like this, right? And we probably also want to change this to a bitmap ID as the fundamental type of the thing as well. Now, if I recompile it, we should be at a place where that actually just works relatively straight through, right? And so if I go through here now and do bitmap display is now bitmap ID, right? Like so. And then I've got stuff like, okay, there's a sound ID and a font ID as well, right? And then down here where we push those things on, like through this sort of system, what I can do is I can add those here where I've got bitmap ID is one of the things I can do, and I've got bitmap ID is one of the things I can set. Hopefully this is really obvious the way that I'm doing this, and it all makes good sense to you. But if not, well, that's what the Q&A is for. Okay, so we've got all of that set, squared away, and now I just need to add that in here since I didn't actually put it in there. And now I just have to take a look. Okay, so whether things should be written, this debug should be written thing is going to go away. That's, I mean, I can tell you right now that stuff's going away. So let's take a look here at what we've got. Let's go there. Bitmap display. What is this? This is when we're printing this out. So the bitmap display.id stuff is really just going to be event.bitmapid, right? And there we go. So now when we actually run this stuff, although we can't really interact with these yet because we haven't solved a few of the problems in terms of permanence, what I'd like to do is now actually just output the debug. I'd like to output a bitmap to our debug ID, to our debug system, right? So the same way that we were outputting things like entity storage index and stuff like that here, I'm just gonna find, like I've got these like, you know, bitmaps here and stuff like that, that I could choose to output. So somewhere where I've got a bitmap ID, what would be a bitmap ID that we could output? For example, we've got a bunch of them here, I think. Let's see. We have loaded bitmap test diffuse, loaded bitmap. What a loaded bitmap. Bitmap. Yeah, do we have any? Well, you know what? I'll just do something like this, where I've got sort of the hero, this hero stuff here. Do we still have the hero bitmaps thing by the time we're actually outputting this guy? I don't know that we do. So we've got that hot entity thing. Yeah, we don't really have, I don't think, any bitmaps for this guy, but I'll see just in case maybe we do. So if we do, I could do something like this, where I say like just output hero bitmaps like .torso or something. Oops, .torso. Okay, so we can. So now there should be a thing where we're like outputting and you can see it right here, like there it is. We just can't interact with them yet. Oh, I guess we can. It's just until it gets deleted is the problem, right? But there it is, right? So now we're actually outputting bitmap displays directly. Unfortunately, like I said, we have some interaction stuff we still need to do, and that just has to do with properly storing information about who exactly we're interacting with. Again, pushing that on the stack, I kind of know. I saw as we went through all this code, it all started assembling itself in my head, so I kind of know how everything should work now, and I'm just trying to kind of go through them and explain each individual step as we go. All right, so now we have gotten rid of a whole bunch of stuff there, because now if you look at what we're actually doing, you can see that debug variable class is basically going away, right? You can see that it's winnowing itself down. It's like smaller and smaller and smaller. And remember, name is now almost entirely like these two things both exist in the event itself. So the only difference between a debug variable now, right? The only difference between a debug variable and a debug event is the fact that a debug variable can store sort of like a group inside it, right? It can say that, well, here's some data that I'm displaying. That's one thing I could say, or I could say here is like a group. But remember, we've got these debug variable links, right? So what we could do is, instead of doing the debug variable thing as something where you point to a variable and then the variable has the group in it, we could choose to elevate that concept up one level, right? Where the debug variable link itself is actually the thing that stores the grouping on top of it, right? That's where I think this is going. Then the concept of a debug variable goes away entirely. It doesn't exist anymore. So I want to look at that. I want to look at that as a possibility. And the thing that I want to look at for that possibility is just to think about, is there anything that that does that we are worried about it doing? Specifically, like when we want to maybe do like drag off cloning of stuff. And I don't think so, because I tend to not really want to drag off clones in ways that aren't going to be at least somewhat more flexible there. So I feel like deep comping is probably okay. On the other hand, I just don't know. I mean, it's always hard to tell whether you're going to be whether that's going to be a bad thing. And at the end of the day, I'm not sure, right? But what we can do at the very least, even if we can't do that, and I guess, like I said, I'm just not sure. I'm not 100% sure which way I want that to go. Even if we couldn't do that, we could decide to just put the debug variable link directly into our debug event and collapse them, right? Because this thing already is like 4 32-bit values long. It could trivially support one of these things right in line with itself, right? So a var group could literally just be this thing right here, right? Hopefully that makes sense. Hopefully that makes some sense. Maybe it does, maybe it doesn't. You know, who's to say at the end of the day? But there you go. All right, so if we wanted to collapse this just a little bit further, that's the thing that we're looking at. How do we actually get there? And the other question too is, does it pose too much of a problem that something like the name is now something that has to get kind of looked up dynamically, right? Because remember, this doesn't have the name in it. It just has a debug record index that you can use to get the name, right? So it has a way of going out to figure out what the name for the thing actually was, but it doesn't actually have the name as a direct pointer. So there is a little bit of that, although I don't know how realistically how much of a problem that would ever pose to us. It's just something that's worth noting, right? Okay, so let's do. Trying to think of which step I want to take next, and I'm not 100% certain which one I want it to be. I think what I would like to do is I think I would like to maybe just try to do that last compression on this guy, and then tomorrow, because we got about 13 minutes left on the stream, tomorrow I'll go through and maybe take a look at some more like some different parts of that. All right, so in here, the way that we're dealing with debug variable links, I guess really, let's see how we're doing our, let's just take a quick look at how we're doing our, like our draw, like our, you know, our iteration where we loop over things. Here is that sort of step where if we get to a var group, which is like here, then we kind of do a little depth push. So we push the depth there. So I'm assuming that if we wanted to, we could pretty trivially have the variable link itself be the thing that gets us to that. Because here's the link, right? So we could do something like, okay, there's a debug variable var, and it's also got like debug variable link like children or something like that, right? So it could have sort of that notion that there's some stuff underneath this particular dude, whoever he is, right? And then that information is just purely, it's just a purely thing that exists in the linking layer, right? In the linkage layer. So if I wanted to do that, if I wanted to get rid of var group here so that it basically becomes this now, right? That's the step we would take next. Can we do that, right? And I guess that debug variable link, the only problem is that we were treating that, oops, that's no good. We were treating that as a doubly linked list thing. So there is a little bit of a problem there, which is that if we point into one of the people of the linked list, there's really no way to deal with the sentinel part. Like, where does that sentinel actually go? And I'm not 100% sure. So it's more like you would need to do something. It's a little janky, right? it's like that, right? It's like you have to sort of have an on-demand created sentinel now at the linking layer, which is kind of ugly. I mean, it's not the greatest thing in the world. I don't know if I love it or not. And it creates a little bit more weight at the link layer instead of it being in the variable layer where it could easily be, right? So you know what I think? I think if you look at Handmade platform.h, you can see inside debug event, there's going to be debug events like open data block and close data block. And open data block and close data block are actually the things which sort of say what that they are sort of the construction of the sentinel. And those things, you know, would have potentially, they have plenty of space to store that ring. So it's kind of a little wonky, and I'm just not sure. I'm just not sure what I think of it. Well, I feel like because I'm so torn on it, I think what I'll do is I'll just go ahead and sort of push through it, go a little bit further down and just see what happens. Because I find like that's usually the only real way to go when you just don't really know, right? When you're just like, I'm just not sure. I'm not sure what should be happening here. So if that was the case, then what's going to happen when we come through here is when we grab out like a group like this, we don't really need to do any of this stuff, I guess. So we've got group. Group is coming in here. It's a debug variable at the moment. So what it would be actually is it would be a debug variable link always. That would actually be the thing that you start with. And so you basically are passing the sentinel. Right. And I suppose you could do something where those things were actually, you know, so here's the thing you could do. Debug variable group. You could do something like this. Right. You could do something like that, and then each one of this just has like children. Right? Which is very close to a way that we did have it before, right? You could do something like that, and that maybe seems a little bit more sensible to me. Okay. So in this case, you'd say, okay, we've got a group. Group equals whatever the tree group is, and that again would sort of be something that just implies that these things that have groups on them now, right? Wherever we have like root group and those sorts of things, those are all going to be talking about a debug variable group pointer, you know, yeah. And then all of this stuff, I'll just do the surgery necessary to make that happen. So that comes like so. And then these guys have to be like just worked through. Again, nothing particularly unusual happening here. Yeah, it's all good. All right. So this will take me a little bit just to kind of work through the changes necessary here. But again, nothing particularly unusual happening. This is just the, if I have a group, we've got sort of that sentinel there. So this is all going to look, I think, just like that, right? Yeah. So again, it's almost exactly the same. There's really not much to it. So in this case, if we have, it's not going to look at the var type anymore for that. What it's actually going to do is say that in this case, we're just going to look to see if there's a children pointer. So if whatever the link is that we're on, if that has a children pointer at all, then we just assume that now is the time for us to do that. Traversal down to it. So we would do link children sentinel. Oops. And off it would go. We can also simplify this iteration. It was not a very well-written iteration, but that's a separate issue. Again, everything gets cleaned up in time. There we go. That's an @ sign. Delist link insert. So a debug variable group is now a thing. So now groups, I guess we would do that to it, I suppose. I think so. Yes. Keep on trucking through that. And this collate create variable group now needs to return a variable group, right? And so when we do create variable, it should not actually be doing this stuff anymore, right? I mean, it should, meaning this is the var, so it should actually do that, and it just needs to also do debug variable group. Okay. Oops, that's not what I want. Actually, I meant that. And then the group itself, right, which is this guy. So the link that got created, the link that gets created for this guy, where we do, when we create a variable group, the link that gets created for the group is just going to be, and I guess we don't even do a var, so it's really only if you actually add this group to another group, right? It's only if this group appears underneath some other group that you actually need a variable for it, which is actually, I guess, a little bit of an improvement over the way that we were doing it before. But yeah, so when we do collate create variable group, it's just creating just a variable group and initializing it, and that's all it does, right? So anyway, let's take a look here. Debug state, collate arena. Let's see what else we got. So this is just collate create variable group and just takes the debug state. This is one. Okay, so in this case, when it does collate add variable to group, that's the point where it would actually that's the point where it actually does something with the naming. So when it creates the actual debug group, it would then also create a variable for that guy. So here's the variable. And I guess really what we need to have is we need to get the link back, right? So the key part here is since we're operating at that link layer, we want to be able to do a thing where when we do collate create variable, we want to be able to see what the link was that got added, right? And so this part right here, where we do collate add variable to group, we want to be able to do essentially this, right? Or when we do collate create grouped variable, right? That's, again, it's doing that link, and we don't have any way of getting the link back, right? So what we want to do here is we want to be able to get that link back. So when we do collate create variable and we pass it the name, we need to pass the debug state as well, and the type. Oops. Okay. So when we go ahead and create that variable, then when we add it to the group, we want to have that debug link come back to us so that we can set the pointer to it, right? So we want debug variable link. That's us creating that link there. And when we add, oops, we are adding the var. And then when we take that link, we just want the children pointer, the child pointer, to be that debug block group. Again, a little bit janky and messed up, and that's just because we kind of have to take this one step at a time, and we still have a few more steps to go, right? That's probably going to be that way. Yeah. Let's return that link. There we go. So I think I got everything there, but I'm not entirely sure. Oh, we didn't. What happened there? Let's see. Iter link var. Okay, so that is a very bad, to say the least, that is a very bad pointer. So what we want to do here is we're going to want to fix this guy. I'm going to go like just a little bit into the Q&A because I'd like to fix that first since we're right in the middle of a change here. I don't really want to leave it until tomorrow and try to remember exactly what I was doing because this is kind of, again, a series of fairly subtle steps necessary to make things end up in a good place. And that can be kind of difficult, especially on stream when I have to talk the whole time and it's kind of hard to keep it all in my head properly. So what's actually happening here, right, is we move that stuff up to the link layer so that we can collapse down debug variable even further from where we had it. And so now what I have to make sure is that when we actually do when we add things to the tree, I just need to make sure that they're actually relatively correct when they get added here. So we're adding to the debug block, we create a variable group that we're going to put our variables in. We create a variable for that one, which we do here, right? We create, we put them in whatever the correct group actually was. We add the variable there, and then we make sure that whoever the children were for this particular entry is going to be the group. That seems correct to me. That looks like what I would expect. I should double check what happens with debug block group. But I don't think really anything else in particular happens with it. Yeah, it doesn't. So when you close the data block, all it does is pop up to the next round. It doesn't touch those groups at all. So I feel like, I don't know, maybe that's an iteration bug of some kind, where this is actually not quite proper. So if link children, when I create these debug links, I don't set the child pointer. That's probably the entirety of it. So debug variable link, when I create one, in here I initialize everything, but I don't initialize the child. So that's almost certainly the problem there. Yeah, and that is what the problem is. Okay, good. So now, again, we're getting a little bit closer. We're simplifying this a little bit further down. We've kind of got relatively good state now. So that debug variable could now effectively just go away, right, if we wanted to. Debug variable actually doesn't have to even be called debug variable. It can just be called debug event, and the debug event can be used directly. And that's what we'll look at tomorrow, and as well as solidifying up our interaction stuff, which I think we could do now very cleanly, and making it so that that'll work as well. So that'll be something that we'll tackle tomorrow. For now, I'm going to go ahead and go to the Q&A in advance of doing the live stream with Sean McGrath. So if you have any questions about what we're doing, please go ahead and ask them now. And if you could put Q colon in front of it so I could see it, that would be great. I see Insobot is continuing to demonstrate its mastery of the English language on the stream. Why call it sentinel instead of head, even though it is a sentinel? I'm not sure what you're asking. Why call it Sentinel instead of head, even though it is a Sentinel? Well, I call it a Sentinel because it's a Sentinel, which is sort of what you're saying it is as well. You don't think it should be called a Sentinel? What's your favorite data structure? Oh. What's my favorite data structure? I don't know. I guess I would say that I really do like doubly linked lists a lot because they're like very easy and they can do a lot of stuff. Unfortunately, I feel like these days with cache coherency being what it is, they're not really that efficient. So it's hard to make them your favorite data structure these days because of performance concerns. So it's like but I feel like in terms of the stuff you can do with a doubly linked list and how easy it is to program, it's kind of awesome. Singly linked lists, I would say that singly linked lists hold kind of a special place in my heart as well, because singly linked lists can actually be done, a lot of stuff can be done with no actual no real atomics. They could with only very basic swap atomics, like you can add something to a free list, a singly linked free list with just one exchange, and they don't have to be checked or anything. They can just, as long as you can serialize the exchanges, you're good. So I don't know. It's hard to say. It's pretty hard to say. Hash tables are also obviously good, very easy to implement and do a lot of stuff. But like everything else, it's really hard to pick. Stegosaurus, I'm not sure if you specified this in a previous post, but do you plan to implement side-scrolling or any kind of platforming alongside the top-down view? No, it is not a side-scrolling kind of game. It does not really do that. I have no game design stuff in there about side-scrolling. So does the InsoBot answer you of... Does the InsoBot answer you if you ask it a question? Does it try to respond? Oh, it does. Sort of. Legend of Zelda has some faux side-scrolling rooms. Yeah, the original Legend of Zelda had when you get an item, but they were really stupid rooms. I don't know why they did that. It's not they weren't good, so I didn't really want any of that. It didn't seem like a good idea. Stegosaurus, what has been your favorite thing so far writing this engine? Probably it was the fact that the software renderer ran so fast, even though we only did the most basic optimization on it. It was kind of fun to see just how fast the software renderer runs. It's kind of crazy. Teroi asks, I had an idea that's probably stupid, but I was wondering if a vector that when deleting an element just left an empty spot that skipped over when iterating would still be cache friendly and still efficient when deleting and inserting. This is slightly over my head though. So the problem with that approach is that, you know, there's nothing fundamentally wrong with that. If what it turned out that you did is you do a lot of deletion, you need your things to be stable, and you don't want to do mem copying, then maybe that's, you know, interesting, right? But you have to understand that there's a lot of overhead that you're going to incur to support this operation, right? Because first of all, you need a way of marking the fact that you've deleted an entry into the vector. So where does that data get stored, right? Do you now have another vector that's like alongside that vector? Do you expand each slot in the vector to include a mark that says whether it's filled or not, right? And now during iteration, which is the thing that you want to be as fast as possible, usually, you're checking every time you increment by one. You got to check to see not only am I at the end, but also do I got to skip this guy or skip some number of guys and so on, right? So, you know, it sounds a little iffy to me. You know, it doesn't sound great. But like anything else, it's not a stupid idea. It's an idea that may have a time when it's valid. And really what it depends on is how are you using this vector? What are the what is the core benefit you're providing there, right? And it, you know, there could be cases where something that did something like that was actually useful. I don't think it would probably be a great general replacement for vector, no. But you know, that doesn't mean that concept couldn't have its place. How about your favorite equation? My favorite equation is, well, I think I answered this before, is linear blend. My favorite equation is we've definitely said this before. How do I get back to some kind of drawing mode here? Hello, Mischief. I would like to draw now, please. There we go. So my favorite equation is definitely like f of a t b equals 1 minus t a plus t b. That is definitely my favorite equation. By far. Do you use DirectX? No, I do not use DirectX. What do you think of Clang C1? Is that C1 or CL? C1. Clang C1 for Visual Studio. I do not know what Clang C1 for Visual Studio actually is, to be honest with you. Any other questions? Mojo123x, if you were doing these compressions, the ones you did today at work, how different would your process be? Well, You know, the process would be basically the same. I would just be skipping a lot of steps. So, you know, I could probably make a much larger jump in a lot of places. So basically the places where you see me go, well, I'm not, that place where I'm scratching my chin, those are actually the places I would be stepping to. And all the places where I'm like, I'm just going to go ahead and move this thing into blah, and I do it. I mean, I'm not going to do it with blah. Usually all of those would probably be just be done in one step. Where I'm just like, okay, I know I'm going to move this thing here, I'm going to put that over there, I'm going to take the struggle and this, and okay, it's that. And then I just like do that change, right? But that's not really very useful on stream because it would be really hard for me to do that stream effectively. It would be hard for me to mentally do that while talking all the time and not mess something up. And also it would be extremely difficult for anyone to have any idea what I did. It's hard enough when I'm doing big changes like this for people to follow, but at that point it would just be forget it. They'd have no idea what I did, right? Because it'd just be like, oh, it was this thing and then it's magically this other thing, and we have no idea like how he got there or why he got there, right? Microsoft is making Clang for parsing intermediate a first-class fully supported system for Visual Studio starting in November. Intermediate to machine is still Microsoft C2. I mean, like I said, that seems like a reasonable idea, I guess. I don't know. You know, I would prefer that Microsoft just did a good compiler. At the end of the day, I don't care about C++, so I actually be fine if they just did a good C compiler. And so maybe that's sort of what they're kind of doing, right? Is like they're saying, let's leave the parsing to Clang because we don't care, and we'll just work on the code gen. And that seems fine to me. That's totally reasonable. Clang is a good front end for C++. It seems like it handles just about anything that people throw at it, even crazy C++ people. I don't really know because I'm not a crazy C++ person anymore. But you know, that's just, it sort of seems that way. But like anything else, I won't really have an opinion until I actually use it in practice and see how it goes. But let's be honest, if I'm real lucky, that day won't ever come because I'll just be programming in JAI or something like that, and I won't have to deal with Microsoft's crappy compiler anymore. How long do you think it will take before someone makes a Linux debugger that can rival Visual Studio's? I mean, infinity long? As far as I mean, there's hundreds of Linux debuggers out there, and they're all lousy. So I don't know. Probably people have to start putting some money behind it, would be my guess. People who actually do low-level programming have to start putting some money behind it. You know? Because it's pretty clear that whatever's happening now just has not led to a good debugger, because there's been tons of them made and they're all lousy. Erdomina, what do you think of programming competitions? Have you participated in any? I have not. I don't have a particular opinion about them one way or the other. Mr. Base 21, what role do you think software security has in modern gaming? Is it not worth wasting CPU cycles to guard against different exploits? How good of a job is the game industry doing to implementing it, and should they be doing more or less? In my opinion, it breaks into two categories, roughly. So there's competitive gaming and non-competitive gaming. So competitive gaming would be something where you're talking like esports and that sort of thing, where there's like, you know, you might win $1 million if you win this tournament or something. So let's assume that we're not talking about that, and we're just talking about all the rest of the games. So just games that I play on my computer by myself. In my opinion, security has zero place in that sphere at all. Game developers should literally never think about security. There should be it should be assumed that every game will ship with the most possibly severe exploits that could possibly occur. That should just be assumed. And then the responsibility for running those things securely should fall squarely on the operating system. There is no question in my mind that that is absolutely the only correct route. And the reason for that is because there are literally thousands of games developed every year. There is no way that each of those people is going to be a security expert, nor do we want them to spend their time doing that. And furthermore, there is no way that each of those games will get the kind of testing and analysis necessary to make sure that they don't have exploits in them. So it is imperative that operating system treat games in a sandbox. They should have done this from day one. There is absolutely no excuse for the reason that they don't. And it is completely ridiculous that Microsoft has still not done this after 7 operating system iterations since they started supporting gaming. It's like absurd. A person should be able to run a game written by a hacker trying to infect their machine on Windows, and it should not be able to do anything, because that is like one of the most primary things an operating system is supposed to do: process isolation. Games do not have to access anything on your machine. They don't have to work with documents. They don't have to save any data that gets used outside the game. They're entirely sandboxable, and there is absolutely no excuse for the fact that this has not been done. It is absolutely pathetic. So that's my opinion on that. And to me, that's like very clearly the right way to go. Competitive gaming is a different thing. Competitive gaming, that is where the game itself is a security problem, meaning that even if I run the game in a sandbox, that doesn't actually help me, because it may be the game itself whose integrity I need to verify, right? Because if I'm trying to prevent someone from cheating in a game, then I need to know that they're running a version of the game that hasn't been modified. That, to me, is a very interesting security problem, and I don't know how you solve that security problem, right? To me, that starts to suggest that you need hardware verification of things, and it kind of gets into a nasty, like, who owns this machine? The person who bought the machine, or the person who, the software vendor, can they verify that the software is proper and all that stuff, right? And so I almost think that, like, in the future, I would actually be okay with the concept that people who are engaged in serious esports use different hardware from other people or something like this. Or that's a separate section of they're two separate things. Because I don't know how you solve those problems. I don't happen to care about those problems, so in my world, we just wouldn't even have them. Like, we just wouldn't have esports. I don't care about it at all. Like, I care about nothing about it. I don't care about cheating in online games. I don't care about esports. They're irrelevant to me. But I realize that they are relevant for a lot of people, and I understand why they want those. Why they want to be able to have a cheat-free experience or a hack-free experience in those cases. And so I would say that if that really is something that needs to get solved, then that itself is a separate security problem. It's a very hard one, and I feel like it probably requires hardware authentication and digital signing, which gets you into a huge nightmare world of, like, who owns this machine and who trusts who, and is Microsoft, like, now telling you what you can and can't run on your machine, and all these sorts of things, right? So that world scares me, and I don't like it, and esports is irrelevant to me, so I just give it up and not have to go that route. But if you actually care about those things, if you're like, Dota is my life or whatever, like, or League of Legends is all I care about, then you have some kind of hard problems to face, which are about, like, do you want to have a machine where you don't actually control the software that's on it, And I don't know, maybe you do. All right, I'm going to go ahead and close down the Q&A. And I'm going to see if we can get the chat link set up for Mr. McGrath. So I'm going to start doing that here so we can be ready. So I'm going to go ahead and close this down. Let's go ahead and do this. Okay. Thank you, everyone, for joining me for another episode of Handmade here. It's been a pleasure coding with you as always. If you would like to follow along with me at home, you can always pre-order the game on handmadehero.org, and it comes with a source code. So if you'd like to sort of experiment and play around with it, you can do that. I also have a Patreon page if you want to support the video series. That's always very much appreciated. We also have a forum site where you can ask questions or view episode backlogs, stuff like that. We also have a tweet bot that tweets the schedule at you. So if you want to know when things are going to be live, that's the thing to tune into. Or when you want to know about special events that are going to happen, like the one that's going to happen right now, where we're doing a live mock debate with Sean McGrath about free-to-play games, which is what I'm going to go set up now. So if you're interested in that, please stay tuned. I'm just going to go ahead and cycle the recording, and then we'll get right to that. So.